Welcome to This Explainer. Today, we're diving into some fantastic insights from Mr. Durai S.K., an assistant professor of computer science at PPG College of Arts and Science, and we're going to unpack the incredible, decades-long evolution of Unix. We'll trace it from its absolute beginnings, see how it fractured into traditional and modern systems, and figure out exactly why it still completely dominates the tech landscape we rely on every single day. Let's get right into it.
So to kick things off, let's just pause and ask kind of a crazy question. How on earth does an operating system designed way back in 1969 still run the cutting-edge tech of today? I mean, it sounds almost impossible, right? We usually think of tech as something that gets obsolete in a matter of months. But here we have an architecture from the moon landing era that's literally out there managing global cloud infrastructures, cybersecurity grids, and yeah, even artificial intelligence.
Here's our roadmap for today. We're going to start with the birth of Unix, look at traditional enterprise systems, shift gears to the modern Unix era, put them in a head-to-head comparison, and then wrap up with their real-world applications.
Section 1. The birth of Unix, the DNA of an operating system.
Think back to 1969. While the whole world was glued to their TVs watching the moon landing, Ken Thompson and Dennis Ritchie were over at Bell Labs quietly birthing Unix. You have to remember, this was an era of massive, room-sized computers that could really only handle one single task at a time. But these two, they built something entirely revolutionary. They laid down a foundation that was just incredibly ahead of its time.
At its core, Unix introduced true multi-user and multitasking capabilities to the computing world. It was meticulously built for stability, portability, and security. And honestly, those fundamental design principles are exactly why it's still the bedrock of servers, workstations, and embedded systems today.
Section 2. Traditional enterprise systems, the monoliths.
Now, names like AT&T Unix, BSD Unix, Sun OS, HP UX, and AIX, these were the absolute titans of the early tech industry. They were heavily guarded, developed by commercial heavyweights like IBM, HP, and Sun Microsystems. These were the massive proprietary systems that major corporations bought when failure just was not an option.
You can really think of these early systems as digital bank vaults. They were highly secure, incredibly reliable, and custom designed for heavy-duty enterprise servers. But, that kind of rock-solid reliability came with a massive price tag. You were paying for expensive proprietary licensing and very specialized hardware. On top of that, administering them was entirely command-line focused. It was deeply technical, totally manual, and required highly specialized experts just to keep the lights on.
Section 3. The modern Unix era, the agile offspring.
Then enter the modern offspring. We're talking macOS, FreeBSD, OpenBSD, NetBSD, and of course the famously Unix-like Linux. This is where the whole paradigm shifted. Now, while commercial juggernauts like macOS are obviously still a huge part of this modern era is largely driven by open-source communities. They completely democratized the operating system, making it widely accessible and super cost-effective for universities, researchers, and global industries alike.
So how exactly did these modern systems take over? Well, first off, they ditched those specialized hardware requirements and embraced user-friendly GUIs, which opened up massive, broad compatibility. Then they basically became the ultimate playgrounds for cloud computing and virtualization. Add in the fact that their open-source nature allowed for just lightning-fast development thanks to global communities hacking away at the code, and they became unstoppable. Plus, they deliver the raw, high performance you need to run modern container technologies. It's an entire ecosystem built from the ground up for speed, security, and total flexibility.
Section 4. Head-to-head comparison, the showdown. When you really look at it, this all boils down to a fundamental philosophical split. On one side, you have the traditional approach, closed, proprietary, commercial systems that are tightly controlled by their vendors. And on the flip side, you have the modern approach, collaborative, open-source communities that are constantly sharing, iterating, and improving code together at breakneck speed.
The transformation between the two is honestly pretty wild. We went from strict command-line-only environments to beautiful GUIs layered right on top of the CLI. We moved away from hyper-specialized, limited hardware to nearly universal compatibility across almost any machine. We transitioned from crazy expensive licensed systems to highly cost-effective alternatives. And maybe the biggest game changer for IT teams, we evolved from painstaking manual administration to having automated tools with frequent community-driven updates. It really was a complete revolution in how we manage computing resources.
Section 5. Real-world applications, the ecosystems.
Now, traditional Unix didn't just pack up and disappear. Not at all. Its legendary stability is literally right now securing our global banking sectors, running massive telecommunications grids, and keeping critical government infrastructure online. Meanwhile, modern Unix has become the absolute engine of the new digital economy. It's powering our massive cloud clusters, running crazy intensive AI workloads, supporting modern cybersecurity frameworks, and hosting pretty much all the web servers you interact with every single day.
It's kind of mind-blowing when you take a step back and realize that a foundation laid way back in 1969 is still the absolute bedrock of today's tech landscape. Whether you're looking at the proprietary stability of a massive enterprise server or the open-source agility of a modern cloud cluster, Thomson and Ritchie's core principles have just completely stood the ultimate test of time.
So I'll leave you with this to think about. As computing continues to evolve at this absolute breakneck pace, as we start moving into quantum computing, advanced neural networks, and whatever comes next, how are these brilliant, decades-old Unix designs going to continue to adapt and power our future? Thanks so much for joining me on this explainer. Keep questioning, keep learning, and we'll see you next time.